So I'm today privileged to welcome you to our today's classes, and the classes are going to kick off starting with some questions in mathematics, and we shall take ourselves through these questions and proceed to see whether we can give the answers or not. So let me just pick my items that I'm supposed to use today in this class. Then we shall be able to proceed to the working of every question. And the first question reads, the equation of a curve is given as. So a curve has an equation given as y is equal to x squared less 3x plus 5. This is the equation of a curve, and from the way it looks like, this must be a quadratic equation that has x getting raised to 2 as the power. We are told that this equation of a curve is parallel to a line given as y is equal to 5x plus 4. So the first equation is the equation of a curve, and that equation is a quadratic equation. And the second equation is the equation of a straight line, and the equation is given as y is equal to 5x plus 4. So the line and the curve are parallel to each other. And someone might actually decide to make a sketch of that, and you're supposed to get something of this sort. So this can be your curve, and you can have this as your line. Correct. So I have my curve as y is equals to x squared less 3x plus 5. And that straight line that is actually parallel to this curve is able to have this equation y is equals to 5x plus 4. So just look at this. And you're told to get the equation of the tangent and the normal to the curve. So you're told to get the equation of the tangent and the normal to the curve. So what do we do first? We are supposed to know that if this is the equation of a curve and this is the equation of that straight line, and that equation of the line is given, and as well the equation of the curve is given, we can literally be able to just use this concept where mathematicians always say that the gradient of a line that is parallel to a curve should be equal to the gradient of that curve at that point where they are actually making an intersection. So where the straight line makes contact with the curve, and at that point where they actually end up becoming parallel to one another, we are supposed to have the same gradient for the two, both the curve and the line, which is now a straight line. So what do we do then? We can just come here and say that if the equation of the line is y is equals to 5x plus 4, then that means the gradient, which is represented by m. In mathematics, the equation of a line must always in the form y is equals to mx plus c. So the equation of a line is always given in the form y is equal to mx plus c. So if the form in which an equation can get written is y is equal to mx plus c, then that obviously tells us that this gradient of this line is 5, because m corresponds to the gradient of the line. And of course, what you need to know is this. You also need to know that c represents the y-intercept, where the line intersects the y-axis. So the gradient of this line is 5. So at this point, if the gradient of the line is 5, then that means the gradient of this curve at that point should also be 5. So that means the gradient of the curve should also be 5 at that point. Now, let's proceed. We do not even know what is the value of x at that point where the gradient is 5. So we shall actually be able to get the dy dx of this, because for us to get an equivalent of 5 as the gradient of this curve, we are supposed to get first the dy dx of that curve. because a gradient of a curve is obtained from its dy dx. So for us to get the gradient, we should first get the dy dx of that curve, and that can give us the gradient. So first, let's get the dy dx of that curve. So we shall proceed. We have been given x squared less 3x plus 5. How then do we get the dy dx? We'll come here and then differentiate. Dy dx means differentiating or getting the gradient function or the derivative function. So the dy dx of a curve can give us the gradient. So for them to get 5, they never took a particular value of x and then substituted in the equation of the curve. They must have taken that value of x at this point that we do not know, where they're actually intersecting the curve and the line. You see, then substituted into the dy dx obtained from this equation. So this equation must first get differentiated for us to get the dy dx, the derivative function. So then the dy dx can actually give us the value of the gradient if the value of x is known. So we have the gradient, we have actually gotten the dy dx from this working. Of course, at the end of the day, we can now be able to get the value of x at that point, where the dy dx can actually end up becoming 5. So the gradient or the dy dx can actually be able to get obtained very easily. Now look at this. We shall just come here and then say 2x raised to 1. What happens with the differentiating? You take the power, multiply by the coefficient, then reduce that power by 1. So 2 times 1, that is 2. Reduce the power by 1, so that is 2 minus 1. That is 2x minus 1. Less 3, then drop the x. Drop the constant as well. That does not have a letter or a variable, which is x. So this is the dy dx. And this dy dx is the one that can help us get the gradient of a curve at any point. So we know that where the gradient of the curve is 5. So this can help us get the value of x very easily. Correct. So we shall then proceed and have 2x minus 3 is equals to 5. So we shall take 3 on to this other side of the equal sign. So 2x is equals to 8. We'll divide both sides by 2. So at the end of the day, our x is 4. So at this point, the value of x is 4. If the value of x is 4, we can get the corresponding value of y for that. How? We know very well the equation of the line is equals to y is equals to 5x plus 4. And I know very well the value of x is 4. So I'll just say y is equals to 5 into 4, then plus 4. Now I know y is equals to 20 plus 4. So correctly, the value of y when x is 4 is 24. That is the value of y. Now, whether you substitute into this equation of the line or the equation of the curve, the answer must be the same. At the end of the day, the answer must be the same. So just assuming, let me just take care of this first, but you can proceed. Okay, so we want to see whether you can still get the same answer if we use the equation of the curve. We have known very well that y is equals to x squared minus 3x plus 5. And I know very well the value of x is 4. So where there's x in this equation, I just place there 4. So I'll say then y is equals to 4 squared minus 3 into 4 plus 5. So that is y is equals to 16 minus 12 plus 5. Look at that. So 16 minus 12 plus 5. So that tells you that now at the end of the day, that is 16 minus 12, then plus 5. That gives you the answer. So if you get back to this, we have actually said that the equation of the line is y is equals to 5x plus 4. And we've said that the gradient is 5. If the gradient is 5, then that means we will come here and say that at the same time the gradient of that curve is 5. Now we should actually come up with what we call the dy dx that can help us get that gradient of 5 at that point so that we can be able to get the exact value of x where the gradient is actually 5. So we shall come and see what we have been given as the equation of the line, which is y is equals to x squared minus 3x plus 5. And we shall be able to differentiate that. We shall actually be able to get 2x minus 3. Yeah, that's the dy dx. So when you place here 2x minus 3 and then equate to 5, we'll get the value of x. This crosses the equal sign, it becomes 8. Then 2 divided by that means we shall be left with x. Then you know very well 8 divided by 2, that is 4. So we have y is equals to 5x plus 4. We want to see when the value of x is 4, what is the corresponding value of y? It can help us get the exact value of that. So we shall now be able to have x as 4. So when x is 4, what is y? So you know very well the y is equals to 5x plus 4. So we shall just come here and say y is equals to 5 into 4 plus 4. So that means y should be 24. Y is equals to 24.